And on the first piece, you need to write probability. And under probability, probability is nothing more than the likeliness of something happening and we do that in fraction form. And it looks a little like this. Here is my line that's going to stand for my probability. If something has 0, which is a fraction, 0 over whatever, if something has 0 probability of happening, it is impossible to happen. The probability of today being Wednesday is 0. If something has a probability of 1, it is absolutely certain it's happening. It will happen. The probability that today is Friday, certain. And then, if 0 and 1 are my extreme low and my extreme high, then halfway through, which is a fraction of 1/2, means that it's like 50-50. It's as likely as not to happen. You would hope that flipping a coin would be a 50-50 thing. And if it's less than 1/2, it's kind of unlikely. If it's more than half, it is likely. Likely to happen. And you just have to think about, let's say you've got a spinner labeled A, B, C, and D. Here's how we show probability. If I asked you what the probability of spinning a bee is, in Mathematica, we put the capital letter P, that stands for probability. Inside the parentheses, you put what outcome you want, and then to find the probability, you make a fraction. On the bottom are all the total possibilities or total outcomes. And on top you put how many good ones, how many favorable outcomes are there. So if you're looking at spinning this wheel, how many different possibilities are there? You could have A, B, C, and D. There's 4 of them. How many of those 4s are the letter B? Just 1 of them. So your probability is 1/4. 1 out of 4 times, you should spin the letter B. If you are flipping a coin, and I ask you the probability of flipping a head, well, on a coin there are 2 sides and only one of them would be a head. Now, take out a blank piece of paper because along with probability, sometimes we have to talk about sample space. Sample space is just a list of all outcomes. Here's my example. Give the sample space for give the sample space for the spinner. Here's kind of how you would show that. The best way to do that is just go SS for sample space, make an equal sign, and then math, when we show a list of things, it's my favorite symbol to make. You put that little brace there, and you just write down how many out the different things you can get. I can get an A, I can get a B, I can get a C, and I can get a D. There's my sample space. What is my sample space if I were flipping two coins? Well, this would be your probabilities, or your sample spaces. You could get two heads. You could get a head and a tail. You could get a tail and a head. Or you could get a tail and a tail. You have only 4 choices there. They're both heads. First one's a head, and the second one's a tail, or the second one's a tail, and the first one's a head, or the second one's a head, and the first one's a head, and 2 tails. And if I asked you what the probability of getting 2 heads would be, you've got the sample space to look at. How many total possibilities are there? 4. How many of them are heads? 2 heads? Just 1 of them. So the probability of that. Your sample space is just a list of all sort of things. Good. Blank piece of paper. Write the word chance on it. Where do you hear the word chance a lot? Oh, yes. More about like probability, because chance is the same as probability, really. It's the same as probability. With one exception. You hear it all the time on the news. When do you hear the word chance on the news? Weather. And what does the weather guy say? There is a
chance it rains.
Somebody said 70% chance of rain. Chance is the same as probability except in percent form. And so instead of doing the fraction from 0 to 1, we do 0% to 100%. So if there's a 70% chance of rain, that falls like right here. That would mean it's likely to rain as opposed to unlikely to rain, which would be down there. You know, if there's a 70% chance to rain, there's a 30% chance it won't rain. You know, it's a good bet that it will rain, but does that mean it's going to rain? I've been outside when they said there was a 100% chance of rain. It wasn't raining, so you have to take all the probabilities and chances. I don't know how they come up with their chances or percent for rain. I mean, they kind of just look at whatever models they are. So chance is the exact same thing as probability except in percent form. You know, 50% means it's 50-50. It could rain, it might not rain, then there's as good a chance that it won't as it will. And then the last piece of paper, ladies and gentlemen, is the word complement. The word complement. And Compliment is not you just saying nice things about people. The complement of an event is the opposite of the event. The opposite. In other words, if I asked you the probability, well, of spinning a seed, say I've got my spinner again, A, B, C, D, and I asked, what's the complement of spinning a seed? The complement of spinning a seed would simply be, what's the probability of not spinning a seed? How many not seeds are there? 3. The complement of spinning a seed is the probability of not spinning a seed. Which would mean, how many not seeds are there? Oh, not seeds, we're not talking not seeds. How many of these are not seeds? A, B, and D, which is 3. The probability of spinning a seed is 1/4. The probability of not spinning a seed is 3/4. What's the complement of flipping a head? Flipping a tail. What's the probability of that? 1/2. And here is what the book makes a very big point about this. If you add probability of an event and its complement, you always get what? Now think about what we just did here. Probability of spinning a seed was 1/4. The probability of its complement was 3/4. If you combine those, you always get 1. 100%, 1, whatever. It's 1. If you add the probability, it'd be like this. What's the complement of picking a boy out of this class? Picking a girl. If I put the probability of picking a boy or picking a girl together, you're going to get 100% probability of 1% complement, whatever. It should be something that's exciting. Alrighty, then your assignment, children, is lesson number 58. 4.